It's 10 a.m. and it's time to get coding. We had a good discussion. I know what I need to do, so let's start with what our environment is. What you're seeing is what I like to call the average development environment, which consists a minimum of 2 monitors. Some people like to have 3 or 4 or more and tilt monitors in different ways. But ultimately, what's important is that you want to have direct visual access to the tools you spend the most time with. The first of which, as a quality engineer, is also same as a developer. That's your integrated development environment. This is a place where you can write code and have that code get automatically compiled and tested and run for you without having to do any command line magic. Next, in our second monitor, we like to put our secondary tools. In this case, the next one is our web browser. Email, being able to Google stuff or look it up on Stack Overflow for common issues, but also being able to talk with our work tracking system. What am I working on? What's the status? Accessing my application itself, and also being able to draw diagrams to communicate with architecturally. As a QE, you're spending a lot of your time in the upper part of the architecture, and so you really have to understand what all those boxes do on the diagram because you're trying to test them in a lot of cases end to end. Next, we have the command line or shell, which is used for doing common build operations, and it's also easier to sometimes do things at the command line versus dragging and dropping in a GUI. And finally, we have some sort of messaging app. This is what we use to stay in contact with a team that is very likely in different locations and in different time zones. And so this becomes our lifeline for being able to keep up to date with what's going on our team. So now that we've explained a bit about what our environment is for doing our work, our first step is figuring out what needs to change. So we drew some diagrams in the breakout discussion, so we pull that up inside of our web browser just so we have something to look at to really understand what we're doing. We're going to have to build a new test suite that drives the UI like normally to create the purchase order, but in order to validate that purchase order, I'm first going to have to make a pretend purchase order so that I can come in and look up that image on my UI. I am, in this case, pretending to be like our third party would do. So with a good architectural understanding of how all the boxes work in our architecture, I have to look at my existing test suite. In this case, as a quality engineer, I'm spending most of my time doing web-based testing using some common framework. In this case, I already have an existing suite of what we're calling acceptance tests, one for a new user, doing a search, making a purchase. And so we already have that test for doing a purchase. So what I'm going to do after that is I now want to write a new test for delivery. And that test for delivery, it's what's going to do that second scenario. I'm going to create that purchase order, and then I'm going to come in and look it up and verify that it aligns with the earlier purchase created. Before I get to coding though, it's very important to do all this manually, because if you can do it manually, you can automate it. So as a QE, the first step here is I'm going to pull up the application on my right, and I'm going to log in through it. I'm going to have an empty environment, and I'm going to do all the steps to go and find a product and purchase it and submit it. Because that's the part I've already automated. I just want to verify it still works that way. I could also run the existing test suite. But then I know that I'm going to have to pretend to be that third-party service to say, hey, I delivered this thing. So I'm going to use a Postman integration, which is a very common and popular tool for doing web service level interactions. And I'm going to use that to make a call out to pretend to be our vendor to submit a purchase order. And so I do that. Then I go into my application and look up the invoice and find that yes, it's been delivered. And here is the signature that I gave it inside of my fake payload. Now that I know how to do it manually, I just need to reproduce this in code format. When it comes to making the changes, this can be really framework specific. I tend to prefer to use the Gherkin format for scenario definition, which uses given, when, then to describe how a testing flows. A lot of frameworks like Cucumber and Parts of Robot, when it comes to UI testing, allow you to define things in this human type language, which is great for being able to organize code. And so I'm going to be doing that in this scenario. But behind the scenes, for each one of those statements, I actually have to write some code in the language of my choice for going out there and executing that, for opening the web page, for loading it, for locating the components in the web page. And so that's what I'm going to write my scenario to do. And then once I get it to a certain state, I'm going to go ahead and run it. And with all these tools too, you can either run it in a headless mode, meaning I can't see what's going on, or the way we like to run it locally is to bring up the browser as it's walking through so we can actually see what it's doing. In this case, I'm using whatever my tech stack is to run my test, and I see it bring up a web browser, go to login, fill in the information, create the purchase order, log back out. Now my new test is going to make a call to that service to say I'm a purchase order with some default image, and then the next part of my test is going to log back in, get to that invoice, and look up and verify that I have all the information that I sent in my original service call. So I'm good to go. I have this test automated. It works locally. What's the next step? Now that I'm comfortable with my test automation, I'm going to want to move it to a centralized location. In this case, I'm going to rely on the fact that I've already set up a pipeline for doing test automation that actually triggers every 24 hours, but also triggers whenever I make a change to it. And so I've only changed this delivery test because I added it new. So when I push that to a central location, it automatically triggers this pipeline. And that's because I'm following CI best practices. In terms of what CI is, or continuous integration, it's best to understand it with the 3 Fowler principles. I make changes to a centralized shared code base at least once per day. When a change is made to that code base, it triggers an automatic build and test. And finally, if something breaks, I fix it within 15 minutes. Whether that means blowing away my change and trying again or fixing it, it's fixed within 15 minutes. So because I'm following those principles, I check on my work and it initiates the test suite I wrote for doing all of our web-based test automation. In this case, the pipeline works by 1, refreshing all the data in the environment so I'm running from a clean state. And 2, I like to run each of my scenarios in parallel. This is because some of these higher level tests can take a long time to run, and so it's best to run them in groups or in parallel so that if each one takes 5 minutes and I have 4 of them, instead of waiting 20 minutes, I only wait 5 minutes. And so in this case, I added a new delivery test suite that runs in parallel to the others. And because I've also connected my CI environment to my messaging, on my lower right, I get notification that at 11 a.m., user John, me as the QE, committed code to this code base and it triggered this pipeline.